Sample problem 7.05. An elevator cab of mass m equal to 500 kilogram is descending with a speed vi which is equal to 4 meter per second when its supporting cable begins to slip, allowing it to fall with a constant acceleration a equal to g over 5, and the figure is given here. Now we have to answer for 4 questions. So the first question given here is, during the fall through a distance d equal to 12 meter, what is the work done on the cab by the gravitational force? That means we have to find the answer for the work done by the gravity. And let's see the free body diagram for this given figure. So here we have the cab, and this cab is tied by a cable, so the tension will be acting in the upward direction and the force due to gravity will be in the downward direction. And then during the fall it covers the distance d equal to how much? 12 meters. That means when it is about to fall, the gravity direction as well as the displacement directions are in the same direction. That means the angle here is theta equal to 0 degree. So here for the first question, the displacement downward direction, the gravity is also in the downward direction. So the answer for theta, which is equal to 0 degree. Now we have to use the formula for the work done by the gravity. So work done by the gravity is given by the rule mgd cosine of theta. So here what is the mass of this elevator, which is 500 kilogram multiplied by 9.8 multiplied by the displacement value here is 12 meter, and then the theta, cosine of theta, which is 0, the cosine of 0 becomes 1. So when you multiply, we got the answer here as 5.88 multiplied 10 power 4 joules. So that is the answer for the first part. So work done by the gravity, which is equal to 5.88 multiplied 10 power 4 joules. Now we have to come for the second question. So what is given in the second question? During the 12 meter fall, what is the work done on the cab by upward pull? That means the tension on the elevator cable. So for that we have to see the free body diagram. That means the tension, which is equal to the force due to gravity, and the displacement will be the downward direction. That means it has an acceleration. So for that, when you write the free body, when you just frame the equation by using the free body diagram, we have the rule, which is the tension minus mg, which is equal to ma, right? So tension is the upward direction, the force due to gravity is the downward direction, and the elevator will have the acceleration. So we have to equate the left hand side equation with the Newton's second law. So that's the reason we wrote the equation like this. Now what I'm going to do, I'm going to take this mg to the right side direction. So what you will get, T, which is equal to ma plus mg. So here we can take the mass as a common term, so which is m multiplied by a plus g, so which is equal to tension. Now once we find the tension, so we have to find work done by the tension. So how we can write the rule? We have to write the rule work done by the tension acting on the cable, which is given by the rule tension multiplied by the displacement d multiplied by a cosine of theta. And here the most important thing, in place of tension, so we have to substitute this value here. So if you substitute, what you will get, m multiplied by a plus g multiplied by cosine of theta. So here the most important thing, the tension will be, because we are finding the work done by the tension, that means the tension will be in this direction and the displacement will be in this direction. So the angle between these two are 180 degree. So here the theta, we have to substitute 180 degree. So this is tension, this is the displacement direction. So the distance, the angle between the tension and the displacement is 180 degrees. So here for this question B part, we have to use the theta, which is equal to 180 degree. But also we have to substitute the acceleration value, because in the question they gave the acceleration a equal to g over 5. So what I have to do, in place of a, I have to substitute g over 5. So if you substitute, what you will get, mass multiplied by g over 5 plus g multiplied by cosine of 180 degree, and also the most important thing, the acceleration in the downward direction. So what we have to do, we have to use minus here. So when you rearrange these equations, what you will get, we will get mass multiplied by 4g over 5 multiplied by cosine of 180 degree, right? Cosine of 180, which is equal to minus 1. So here we have to substitute the value for the mass of the elevator, which is 500 multiplied by 4 multiplied by 9.8. Cosine of 180 is minus 1 divided by 5. So here we got the answer as minus 4.70 multiply 10 power 4 joules. So this is the work done by the tension. Clear? Now in the third part, what they ask, we have to find the net work done on the cable, on the cap during the fall. That means we have two work done here. One is work done by the gravity, which is our first part, and then the work done by the tension, which is our second part. So what we have to do, we have to add these two values. So as we know, the net work done, which is equal to the work done by the gravity plus work done by the tension. Clear? So now I have to substitute the value here. The work done by the gravity is 5.88 multiply 10 power 4 plus, and then the work done by tension, which is minus 4.70 multiply 10 power 4. So here when you just equate, when you just add these two numbers, so 5.88 multiply 10 power 4 minus 4.7, because plus into minus is minus, so we have to subtract this number. When you subtract, we got the answer here as 1.18 multiply 10 power 4 joules. So this is our net work done. Now we have to answer the last question. What is given in the last question? What is the cap's kinetic energy at the end of 12-meter fall? So that means here they ask about the final kinetic energy, because the initial kinetic energy, the initial speed of the value is given. So what's the value of the initial speed? In the question, they gave the value of VI as 4 meters per second. So if you read the first part of the question, or I can just show you the question one more time. You can see the question, because the cap is come with some initial speed of 4 meters per second. So that means here they ask about what is the final kinetic energy. So that means we have to find a kf value. So what we have to do, we have to use the formula. What's the formula? As we already studied, the work energy theorem. That means the net work done, which is equal to a change in kinetic energy. So what is change in kinetic energy? Kinetic energy final minus kinetic energy initial, so which is equal to our net work done. That means they ask the answer for the final kinetic energy. So what we have to do, we have to rearrange this equation. So when you rearrange this equation, so what you will get, the final kinetic energy, that means the Ke final, which is equal to work, that means the net work done plus kinetic energy initial. Clear? Now we have to substitute the value, because the net work done, which is the answer for the third part. But what is the initial kinetic energy? We know the formula for initial kinetic energy. So that means work done, the net work done plus half mvi square. So here I'm going to substitute the value. First I'm going to substitute the value for the net work done. So let's we take the answer from the third part. The net work done value is 1.18 multiply 10 power 4. 1.18 multiply 10 power 4 plus half the mass of the elevator is 500 multiplied by the initial speed, which is 4 meters per second. That means 4 square. So here we got the answer as 1.58 multiply 10 power 4 joules. So this is the answer for kinetic energy final. So this is the answer for this question. Thank you.